Look up at the sky. Doesn't matter where you're standing or what patch you pick. Count the stars you can see. Then imagine what you cannot see. For every star visible to your naked eye, there are another 10 million hiding in the same galaxy. 100 billion stars in our Milky Way alone, most of them older than our sun, many of them with planets. And as far as anybody has been able to tell, none of them are saying a word. The sky is silent. That ought to disturb you, not in a small way, in a big way. Because when you work out what the silence means carefully, step by step, using nothing but physics, you arrive at one of two conclusions. Either something we do not understand is going on with the universe, or something we do not want to understand is going on with the universe. I want to walk you through both, because this puzzle is one of the oldest and best puzzles I know of, and the candidates for an answer are not a gentle bedtime story. My old friend Enrico Fermi asked the question out loud first, as far as I know. He was having lunch with some colleagues at Los Alamos, and the conversation wandered to flying saucers, which were in the newspapers at the time, and then wandered to the broader question of whether there might be other civilizations out there. Fermi listened for a while. He chewed on it, and then suddenly, right in the middle of the conversation, he stopped and he said, "Where is everybody?" That was 1950. He was not making a joke. He had just done the math in his head, and the math did not add up. The stars are too many. The time available is too long. The silence is too complete. Something was wrong with the picture. And in the years since, the more we have looked, the more wrong it has gotten. We are going to figure out what. First, let me give you a feel for the numbers, because without the numbers, the argument is a pile of words with nothing under it. Our galaxy contains roughly 100 billion stars. Some people say 200 billion. Some say 50. Take any number in that range. It makes no difference for what I am about to say. There are plenty. How old is our galaxy? About 13 billion years. How old is the universe? A little older, around 13.8. How old is our sun? 4.5 billion years. Our sun is, by galactic standards, young. Relatively speaking, we live on the front porch of a very old house. The galaxy had been doing its job, forming stars, cooking heavy elements, building planets for 8 or 9 billion years before the sun ever lit up. Think about what 8 or 9 billion years means. Here is one way to see it. The universe produced us starting from hydrogen. That took 13 billion years, from the beginning all the way to you sitting there, reading equations or watching this lecture. If the universe had needed another 9 billion years to warm up before we showed up, it had enough leftover time to build us twice, maybe 2.5 times, with time to spare for lunch in between. Other civilizations out there could have gotten a head start on us of millions of years. 1 million years is a long head start. 1 billion is hard to even imagine. Let me try. 3,000 years ago, human beings were figuring out how to smelt iron. 150 years ago, we were starting to harness electricity. 70 years ago, we left the Earth for the first time. That is the full run from bronze tools to rockets, and the whole thing fits inside 3,000 years. Now imagine a civilization 1 million years ahead of that. Not 3,000. 1 million. What do they know? What can they do? I cannot tell you. Neither can anybody. But whatever it is not nothing. And 1 billion years ahead? Forget it. You and I are not equipped to think about that. How many such civilizations should exist? Here is where the numbers start to pinch. Suppose life is rare. Suppose of all the stars in the galaxy, only 1 in 1 million produces a civilization capable of looking up and asking this question. 1 in 1 million out of 100 billion stars is still 100,000 civilizations in the galaxy. Make it 1 in 1 billion. That is still 100. 1 in 100 billion? 1. That would be us, and nobody else, ever, in the entire galaxy. We do not know the real number. But for us to be alone in the galaxy, the chance of a civilization arising at any given star has to be close to 0. Not small, essentially 0. anything bigger than that, and there should be company. So let us assume, for the sake of the argument, that we are not a uniquely special accident. Let us assume at least a few civilizations have emerged out there, somewhere at some point in the long history of the galaxy. Where are they? We keep tightening that question until it hurts. Here is the second piece of the puzzle. Let us ask a simple thing. Suppose just one civilization, not all of them, just one, decided to spread. Not to conquer anyone, not even to contact anyone, just to send its descendants, or its machines, from one solar system to the next over many generations. The way you might imagine a species of bird working its way from one island to the next over a very long time. How long would it take such a civilization to reach every part of the galaxy? The galaxy is about 100,000 light years across. Light itself takes 100,000 years to cross it. Nothing physical can go faster than light, but anything physical must go slower. So let us pick a speed. 1% of the speed of light. That is crawling, by cosmic standards, much slower than anything we think is impossible. At 1% of light speed, crossing the galaxy takes 10 million years. 10 million years. Compare that to the age of the galaxy. The galaxy is 13 billion years old. 10 million years divided by 13 billion is about 1 part in 1300. If you took the entire history of the galaxy and compressed it into a single day, 10 million years would be a minute and 6 seconds. Just over a minute. So a civilization, moving at 1% of light speed, fills the galaxy in roughly the time it takes to lace up your boots on a cosmic clock. And I was being slow. 10% of light speed is not obviously impossible. Even 1/10 of 1%, still many times faster than any spacecraft we have ever built, covers the galaxy in 100 million years. Still a blink. Think about what this means. For the galaxy to be empty today, you need every civilization that ever arose, across 13 billion years, across 100 billion stars, to have not spread. Ever. Not at all. Not accidentally. Not even a little bit. Because if a single civilization at any time ever got the urge to expand, even at a snail's pace, the galaxy would have filled up long before you or I were born. Long before the dinosaurs. Long before the first cell on Earth. We would not be searching for them. We would be digging them up. We would be finding old outposts on asteroids. We would be picking up radio chatter from settlements a few stars over that had lost contact with the home world 1 million years ago. Something. Anything. A useful image. Drop a drop of ink into a glass of water. Do not stir. How long does it take to spread? A few minutes. The glass is a few centimeters across. The drop moves at about 1 millimeter a second, and diffusion handles the rest. Scale that up. The galaxy is the glass. Civilizations are the drops. There have been, potentially, many drops over cosmic time. Even the slowest drop spreads faster than the glass is old. And yet, the water is clear. No ink. Nowhere. That is not a small problem. That is a very large problem. Fermi's question is asking about that problem. Not where is the nearest alien we might talk to, but where is the evidence that anyone, ever, anywhere, did anything? Let me tighten the screw further. Some of you might be thinking, well, maybe civilizations do not like to travel. Maybe biology is fragile. Maybe living creatures cannot survive 1,000-year journeys between stars. Cellular repair is tricky. Radiation is a killer. Breeding populations are hard to keep going. Fair points, all of them. Maybe civilizations never go in person. But they do not need to go in person. A mathematician friend of mine, John von Neumann, worked out a gorgeous idea years ago. The idea is a machine that does two things. The machine does some useful task. The machine also builds a copy of itself out of whatever raw materials it finds nearby. Rocks, ice, metals and asteroids. Give the machine some instructions, give it time, and it makes another of itself. Send the copy to the next star. That copy makes 2 more. The 2 make 4. The 4 make 8. You know about doubling. Doubling is the fastest kind of growth we know. 2, 4, 8, 16, 32. After 10 doublings, 1,000. After 20, 1,000,000. After 30, 1,000,000,000. After 40, 1,000,000,000,000. After 47 doublings, you have more copies than there are stars in our galaxy. So how long does a self-replicating probe take to fill the galaxy? The travel time between nearby stars at modest speeds is a few hundred to a few thousand years. Let us be generous and say each generation, travel plus replication, takes a full 1,000 years. 47,000 years to do 47 generations. 47,000 years. In 47,000 years, a single civilization, in a single star system with a single engineer building a single prototype, could cover every star in our galaxy with its descendants. Every star, every planet, every moon, every asteroid, every ball of ice in every lonely outer system. And the cost? Nothing, essentially. You build one machine. After that, the machines build themselves. They mine what they need. They travel on their own. The first machine is the only investment. Everything after that is cosmic compound interest. So if even one civilization, ever, anywhere in our galaxy over the last 13 billion years, had the idea of self-replicating probes and acted on it, the probes should be in our solar system right now. They should have arrived long before we did. They should have watched the dinosaurs come. They should have watched the dinosaurs go. They should have watched the first fish crawl out of the sea. They should be watching us. What would such probes be doing? Whatever their makers told them to do. Mapping, observing, reporting back, mining, building more probes, building other things. Whatever it is, it would be ongoing. It would be active. It would leave fingerprints. Modified asteroids, strange signals between machines, anomalous infrared sources where no infrared ought to be, observed over a long enough time, changes that nobody's physics textbook can account for. We have looked. We have scanned the sky in every direction we know how. We have searched for anomalies. We have looked at the asteroids. We have looked at the moons of the giant planets. We have not, so far, found any trace of any such thing. Some people argue maybe the probes are small and polite and they just watch and they leave no trace. But this argument has a weight problem. For it to work, every civilization that ever built a probe and every probe ever built has to have the same discretion. All of them. Or nobody ever builds them in the first place. Since the probes are cheap and the idea is obvious, it is hard to believe nobody ever built them. Somebody would have, somewhere, and the result would be visible, unless nobody ever did, unless the kind of civilization that would build probes does not exist, or does not exist for long. Can you feel that? That small chill on the back of your neck? Every piece of evidence we accumulate points the same direction. Either civilizations are unbelievably rare, or something is happening to them before they spread. Keep pulling. Let me tell you about something that no civilization, however advanced, can hide. Waste heat. Every time you do useful work, you produce heat. When the refrigerator cools the food inside, it warms up the kitchen. When you run a computer, the processor heats up. When an animal walks around, it radiates body heat into the air. This is the second law of thermodynamics, and there is no way around it. There is no technology that will ever be invented, no clever trick that lets you do work without producing waste heat. It is built into the structure of the universe. Freeman Dyson, who is a friend of mine at Princeton, pointed this out some years ago. He said a civilization that grows large enough will eventually be using a very large fraction of the energy its star puts out. Maybe they build structures around their star to catch that energy. Clouds of collectors, swarms of panels. You do not need to see the structures. You just need to notice the star is behaving wrong. Instead of shining at the colors of a hot surface, the star will be shining mostly in the infrared. Warm, but not hot. The signature of a star whose energy has been harvested and dumped back out as waste heat. We have looked at millions of stars, catalogs of millions. We have looked for exactly this signature. We have not found it. Not around our nearest neighbor. Not anywhere in our sweep of the galaxy. You might say, maybe they are efficient. Maybe they do not need that much energy. But efficiency has a ceiling. You cannot compute without producing heat. You cannot build structures without losing some energy to radiation. Even a civilization that wanted to be invisible would be radiating heat. Not a lot, but some. And we would see it in the right part of the infrared sky. We do not. Look beyond our galaxy. There are, at a minimum, hundreds of billions of other galaxies in the observable universe. We can see a lot of them. Some of them we see as they were billions of years ago, because the light took that long to reach us. We are looking at an enormous sample of places and times. You would think, somewhere in that huge sample, some galaxy would have been colonized by an ambitious civilization, and the whole galaxy would look wrong, shifted toward the infrared, unusual, peculiar. We see none of that. The galaxies we see behave exactly the way physics predicts for galaxies that contain no engineering projects larger than natural objects. No cities around stars. No swarms of collectors. No industrial processes at the scale of star systems. The universe we can see looks untouched. 100 billion stars in our galaxy. Hundreds of billions of galaxies beyond ours. 10 billion years of opportunity. And the whole thing looks like a freshly set table. Plates laid out. Nobody has sat down to eat. Nobody has even pulled out a chair. This is what needs explaining. Not just local silence, cosmic emptiness. Let us go through the candidates for an answer, one at a time. Candidate 1. Maybe life itself is rare. Maybe the chemistry that leads from dead molecules to something that copies itself is so rare, so improbable, so fragile, that it almost never happens. The galaxy is empty, on this view, because life almost never gets started. This is a respectable candidate. I do not want to brush it off. We really do not know how life began. The jump from a collection of organic molecules sloshing in a puddle to something that copies itself is a jump we have never observed. We have not reproduced it in the laboratory. We do not know how likely it is. It might turn out to be absurdly improbable. We might really be the only inhabited planet in the visible universe. If so, the silence explains itself, and we can go home. Before you go home, consider a few facts. Life on Earth appeared early, very early. As soon as the planet cooled enough for liquid water to sit on the surface, within a few 100 million years, we find evidence of living things. If life were a 1 in a trillion fluke, you would expect it to take a very long time to appear on any given planet. On Earth, it did not. It showed up almost as fast as the physics allowed. That suggests, mildly, that chemistry is eager to become biology when given the chance. Not proof, a hint. Another fact. Organic molecules are everywhere. We detect them in interstellar clouds. We find them in meteorites, amino acids, sugars, the building blocks of biology, sprinkled through the galaxy like flour on a bakery floor. The raw materials are common. And a third fact. We are increasingly confident most stars have planets. A lot of them. The galaxy is not dry. Worlds are common. So life has common raw materials, common homes, and appears fast when it can. None of this proves life is common out there. But none of it supports the idea that life is so rare we are alone. And here is something that matters in a minute. Our argument does not require life to be common. It requires technology to be common. Or, actually, it requires it only once, somewhere in the history of our galaxy. Just one civilization, any time, any place, that spreads. And the whole galaxy is changed. If life is even a bit common, getting one technological species over 10 billion years across 100 billion stars seems like a low, low bar. So rarity of life may be part of the story. It is hard to stretch it far enough to explain the whole silence. We would need life to be so rare that nothing ever made it to intelligence. Anywhere. Ever. Possible. But strange. Let us keep going. Candidate 2. Maybe civilizations arise and grow and get clever, but the cleverness is the problem. Technology grows fast. Wisdom grows slow. At some point, technology gets ahead of wisdom by enough, and the civilization does something stupid and destroys itself. Nuclear war. Biological accident. Running through its planet's resources faster than the planet can replenish, some disaster that reliably ends civilizations around the time they reach the level of being able to build probes and listen to the sky. This candidate is uncomfortable to sit with, because you can feel it in your own gut. Our species has weapons. Our species has not yet proved it can keep them from being used. You can imagine every species hits this cliff, that every intelligence climbs the ladder of technology and falls off near the top. If it were true, it would explain the silence. Every civilization ends before it spreads. But there are problems. A civilization that ends does not just disappear without a trace. It would have radiated. Its radio, its television, its power. Those signals would be traveling outward at the speed of light, and would still be reaching us now, from dead civilizations of 1 million or 1 billion years ago. We should be picking up the final broadcasts of extinct species. The last song, the last news report, the last scientific paper, followed by silence. We do not hear those. The sky is not full of ghosts. It is empty. And the stronger problem. This candidate needs every civilization over all time to destroy itself, not most, all. Because if 99% destroy themselves and 1% survive, the 1% spreads and fills the galaxy. You need a perfect extinction rate, no survivors, ever. That is a very strong claim. It says intelligence is, by some iron law, self-defeating. Always and everywhere. Not sometimes, always. That is not a claim about other species. That is a claim about the nature of intelligence itself. And it has a sharp consequence for us. If it is true, we are also going to destroy ourselves. Because we are an intelligence. And intelligences destroy themselves. There is no exit. Maybe. But the numbers still feel wrong. Perfect extinction is a very thin line to walk. Nature rarely hits exactly 100% of anything. So let us hold this as possible and keep going. Candidate 3. Maybe civilizations grow up. Maybe, once they reach a certain level of development, they lose interest in expansion. They turn inward. They build beautiful internal worlds. They practice contentment. They sit quietly and leave the stars alone. On this view, the universe is full of mature, wise civilizations, and none of them feel like bothering the rest of us. It is a lovely picture. I would like to believe it. It does not hold up. The problem is the same problem that keeps showing up. Averages do not save you. You do not need every civilization to want to spread. You need one. And the one that does, spreads. And once spread, the galaxy is no longer empty. So for the grown-up and quiet candidate to work, you need every civilization, every single one, over all of time, to have made the same grown-up choice. No outliers, no young rebels, no species whose culture happened to value exploration over contemplation. No accidents. Think about human beings. How many different values, goals, and ambitions does one species on one planet produce? We cannot get 100 people in a room to agree on what to have for dinner. Imagine 100 species, each on its own planet, shaped by its own history. You expect the whole set to independently converge on the same cultural conclusion? That nobody ever wanted to go exploring? If you really do require such universal cultural agreement, then it is not a cultural phenomenon anymore. It is a physical constraint pretending to be a cultural one. Something out there is forcing every species to the same choice. which is a new question, hiding behind an old one. So the quiet, mature civilization story is not an answer. It is a disguised question. Pull off the disguise and you find what is forcing the choice. Candidate 4. Maybe we are in a zoo. Maybe the galaxy is full of civilizations, but they have agreed all together not to contact us, to leave us alone, to let us develop undisturbed, to preserve the Earth as a kind of nature reserve for primitive intelligence to evolve in peace. For this to work, you need every civilization in the galaxy to cooperate, all of them, over billions of years, without communicating faster than light, without enforcement, without exceptions. One single rebel, one single curious graduate student on some planet 2 million years ago who broke the rules, and the zoo is broken. There was a landing. There was a sign. There was a signal that said hello. None of that happened. Not once. For a zoo to hold, you need perfect coordination among a vast, diverse, uncommunicable set of agents. That is not politics. That is magic. I do not believe in magic. Neither should you. The zoo is out. We have now eliminated rare life, self-destruction, grown-up quietness, and the zoo. Each one tried to explain the silence by making a universal claim. Every civilization is rare. Every civilization destroys itself. Every civilization loses interest. Every civilization cooperates with the rules. And each of these universal claims dies on the same hill. The sheer number and diversity of potential civilizations is too much. Unanimous agreement, unanimous extinction, unanimous anything does not work across cosmic diversity, unless something else is doing the enforcement. Notice the shape of the problem. Every candidate we have looked at has required that all civilizations behave the same way. All rare, all suicidal, all contemplative, all cooperative. Each fails because universal behavior across independent species on independent planets is not realistic. Unless you can find a reason rooted in physics or logic that forces independent agents, without communicating, without coordinating, to independently arrive at the same behavior. That would not be cultural. That would be structural. The structure of the universe would be telling every civilization, you must behave this way or you will not survive. Is there such a structure? I think there might be. I think the physics of this universe, specifically, may produce exactly that kind of forced convergence. And if it does, the silence is not a mystery, it is a symptom. The symptom of a universe in which survival requires quiet. Let me build the argument. You tell me whether it persuades you. Imagine you are a civilization. Pick any stage. You have emerged on some world, developed tools, learned language, built science. You are starting to look at your sky. You are starting to wonder whether you are alone. You have the means to send signals or to go silent. And you face a single question. Should you announce yourself? Before you answer, I want you to think about what you can know and what you cannot know. What you can know. First, no signal travels faster than light. Any message you send will take years, centuries, sometimes millennia to reach anyone. Any reply takes just as long coming back. Second, you cannot see what anyone out there is doing right now. You can only see what they were doing when the light left them. The older the civilization, the older the information. Third, technology can change quickly. A civilization that looked harmless 1,000 years ago may be something very different now. You have no way to check. What you cannot know. You cannot know if a civilization out there is friendly. You cannot verify intent at a distance. Intent is a property of minds, and you are looking at light that is old. You do not know whether the species that sent the light still exists. You do not know what they will do with the information that you exist. You cannot confirm anything, because the universe is too big and time is too long. And here is what you do know that is uncomfortable. If they decide, for whatever reason, that they want to harm you, they can do so at a distance. They do not need to visit. They can hurl a rock at you, very fast. A piece of iron the size of a truck, moving at a large fraction of the speed of light, arrives at your planet with the energy of a major asteroid impact. No advance warning. Your atmosphere ignites. Your surface boils. Your civilization ends in a flash. This is not science fiction. This is physics. Kinetic energy is 1/2 times mass times velocity squared. At relativistic speeds, even small objects carry enormous energies. And to aim, the attacker only needs to know where you are. You told them. When you broadcast, you gave them the address. A stone thrown 10,000 years ago at high speed arrives at your address. That is the whole recipe. So, you are thinking about broadcasting. You are thinking about making a noise. You are thinking about saying hello. Let us be honest about what is at stake. Are there civilizations out there that are friendly? Probably. Maybe most of them. Are there civilizations out there that are hostile? Maybe a few. Are there civilizations out there that are neither, just cautious, just wary, working out their own version of this same problem? Almost certainly. The argument comes together when you notice they cannot verify your intent either. They are looking at you and asking the same question. Are these people harmless, or are they going to grow up and become a threat? They cannot know. They cannot see into your mind. They are looking at an old signal. You might be very different by the time they decide what to do. The civilization that reasons carefully about this, the one that is neither foolish nor paranoid, just coldly careful, arrives at an uncomfortable place. They cannot afford to be wrong. If you turn out to be dangerous and they ignored the warning signs, the cost to them is extinction. There is no second chance. So the careful, sensible civilization considers its options, and the options are not nice. Option 1. Stay silent. Do not reply. Do not engage. Hope the young, loud species does not grow up into a threat. Hope it dies off on its own. Just do not be noticed. Option 2. Remove the threat preemptively. Send a rock. Not out of malice, out of caution. The young species at some point will become able to reach us. We do not know what they will want. We cannot afford to find out. Better to erase them quietly now than to fight them in full strength later. Option 3. Try to communicate, verify, negotiate. But this option takes centuries. You send a signal. They take a century to receive it. They take a century to send a reply. You take a century to check whether the reply is genuine. In the meantime, they have grown. They have advanced. The civilization you negotiated with may not be the civilization that exists by the time anything is decided. So option 3 is weak. Option 2 is brutal but rational. Option 1 is easy, but risks having to do option 2 later. Now extend the logic. You are not the only one doing this reasoning. Every sensible civilization is doing the same math. They are all looking at each other the same way. They are all considering the same options. And the stable position, the one where everyone converges, is quiet. Stay quiet. Do not broadcast. If you hear someone else broadcasting, think about option 2. If you can confirm the source, think about it harder. Picture this across the galaxy. Every civilization that ever matured enough to reason about the problem reached this same conclusion, independently. Silence, caution, and, when necessary, a preemptive stone. The result is what we see. The galaxy is full. The galaxy is also silent. Because the ones that learned to be silent survived, and the ones that did not survive long enough to be noticed. Every signal that was ever sent loudly and answered loudly was eventually followed by a silence, because somebody, somewhere, decided not to take a chance. This is not my idea. I did not invent it. It follows from the physics. The speed of light is physics. The inability to verify intent is physics, because information about minds cannot be extracted from electromagnetic waves without interpretation. The ease of kinetic attack at great distance is physics, and the structure of rational decision-making under uncertainty is mathematics, which is as hard and as unyielding as physics. Put all of these together and you get an argument whose conclusion is that the universe punishes noise. You and I, as a species, have been making noise for most of a century. We started quiet, then we got louder, then we got deliberate. We have broadcast messages at specific stars. We have sent spacecraft out with plaques and records explaining who we are, where we came from, and how to find us. Every time we have done this, somebody has asked, "Is this a good idea?" And the answer has mostly been, "Oh, sure, it is fine. Nobody is going to hurt us for saying hello." If the reasoning I just walked through is correct, that answer is wrong. It is wrong in a very old way. It is the answer a child gives before they have understood how the world works. It is the answer you give before you have noticed the shape of the forest around you. The silence you see when you look up is not emptiness. It is the held breath of a crowded forest. It is a room of patient listeners, each trying to decide whether the noise they hear is worth responding to. And we have been making the noise. Now let me tell you why this is still a puzzle, even if I have talked as if I know what the answer is. I do not know. Nobody knows. What I have given you is one of the answers the physics allows. It is a frightening answer, but it is not the only one that remains. There is another possibility, also frightening, but in a different way. The possibility that we are early, that civilizations are, for some reason, just starting to arise in cosmic history, that the galaxy has been quiet for 10 billion years not because everyone is hiding, but because nobody was here yet. On this view, we are one of the first. The galaxy is empty because the party is just beginning. This is a cheerful thought until you notice its implications. Of all the positions a civilization could be born into, being among the very first is statistically peculiar. There should be more civilizations later than earlier, just by the way probabilities work. For us to be early, something must have delayed the rest, or something must have rushed us. Either way, we are in a strange spot. And it gets worse. If we are early, then later civilizations will look out at a galaxy where they see older civilizations, including us. If we survive and spread, those later civilizations will see us. We become the signal. And by the reasoning of the previous argument, signals attract attention. So even if we are early, we inherit the problem as we grow. Another possibility. Maybe there is a barrier somewhere on the path from dead rock to galaxy-spanning civilization. Maybe most planets fail to get to life. Maybe most life fails to get to complex life. Maybe most complex life fails to get to intelligence. Maybe most intelligence fails to get to technology. Maybe most technology fails to survive its own childhood. Somewhere in that chain, something is hard. Something kills almost everything that tries. A filter. The interesting question is where the filter sits. Is it behind us? Did we already survive the hard part without knowing it? Then we are lucky, and the future is open. Is it ahead of us? Then we are about to run into whatever has been killing civilizations for 10 billion years, and we have not yet noticed it, and it is waiting. You do not know. I do not know. Both positions are consistent with the data, and the filter might be the very thing we just described. A reason nobody survives past the noisy phase. A reason all sufficiently advanced civilizations either learn to be quiet or get quieted. The universe keeps its dinner quiet, because the ones who talk during dinner are not at the table anymore. Here is what I think you should take from all this, even if the specifics stay uncertain. The silence is real. It is not a failure of our instruments. It is not a failure of our imagination. It is a fact about the sky, and it demands a strong explanation, because the sky should not look the way it looks. And the strong explanations are all, in their own ways, sobering. Either we are alone in a way that is deeply strange, or we are not alone, and the others have learned lessons we have not yet learned, and they are listening from shelters we have not thought to build. Maybe nobody is home. Maybe everyone is home. Maybe the rules are different from what we guessed. I cannot tell you. What I can tell you is that this is not a trivial puzzle, and the answers on the table are not cozy ones, and the physics is not finished with us yet. When Fermi asked his question over lunch, he was not making idle conversation. He was pointing at a wound in the picture of the cosmos we prefer to carry around. We like to imagine the universe as a crowded, friendly place, full of beings we might someday meet. The universe our telescopes actually show us is not that. The universe our telescopes show us is enormous. It is beautiful. It is silent. And we are the ones who walked into the room and started talking first. Maybe nothing is listening. Maybe everything is listening. The physics allows both. If I were betting, I would bet that the cold logic of light speed, the impossibility of verifying intent, and the fact that very small objects at very high speeds carry very large energies are going to be central to whatever the final answer turns out to be. Not because I enjoy that. I do not. It is one of the least comforting conclusions physics has ever led me to consider. But physics has a long history of being right whether I like it or not. So next time you are outside at night, look up. Do not look at the sky as empty. Look at it as a room full of closed doors. The stars are the light from behind those doors. The silence you hear is not nothing. It is the sound of attention. We have been making noise for most of a century. Maybe nothing is out there to hear it. Maybe everything is. I would like to know what you think. If you had to guess, after what we have just walked through, which answer feels most likely to you? Is life rare beyond imagination? Is the cliff of self-destruction universal? Are we in a quiet forest where the older species have learned loudness is death? Or is the real answer something we have not yet thought of? Tell me your guess. Sleep on it. An instinct about this one, about whether the universe is crowded or empty, is worth thinking about in the light of day. That is enough for tonight. Let me know what you decide.